So here's an example from another textbook, and so this is about some salads and dressing association. Wanted to see if a higher proportion of Americans, higher than 85%, are eating salads at least once a week. So they went out and did a test. Probably paid some statistician a lot of money to go do this. So what the claim is, here's the claim that the association is making, that more than 85% of Americans eat salad at least once a week. And I got this right here, that the nutritionist suspects the percentage is higher than this. So that's the claim. Now, to test this, we're going to try to show the opposite is true. So if the opposite is true, that means 85% or less. And that's what, even though this is an equal, it's always the opposite. Well, see, it can be, H1 can be the opposite also. But in this situation, I decided that since you're trying to see that the claim, see if more than 85% is of people eat salad every day, once a week, I'm going to use H1 as being the claim, that it's greater than 85. And this will be if that's not true. Okay? So that's the null hypothesis. So then I found p-hacks. I need to do that for the z-score calculation. It said there was 171 people out of 200. So a little bit more than 85%. And if you look at that, you could probably almost instinctively say, yeah, that's not that much different. But what you got to be careful of is this is based on one sample. Samples can vary. It might happen that this is too high, even though it's it's only a 0.5% higher. It's not going to be, as we'll see in a minute. But you can't just say, "Yep, that sample result is higher than the 85," so we're gonna say, "Yep, it's significantly different." Okay, or you can say, "Oh no, it's close." I can't say it's significantly different. So you gotta run the test. Either find a p-value or compare it to some critical value, and that's what we'll show next. I made the claim, I wrote my hypotheses, now I'm finding my test statistic, and that's just a z-score in this case. So there's the number from the sample, there's that's what we think the center of the sampling distribution is. I use that value to get the standard deviation. And when I did all that number crunching, I came up with a z-score of 0.198, pretty small. Then to find the critical value, if I'm choosing to do this instead of using z-score or p-values, I've got a right-tailed test, because it was greater than. They told me the 10% level, or the point one, how do I say this? The 0.1 level of significance. That doesn't come out right. 10% level of significance. So it's a right-tailed test, so our critical value is 1.28. And we're going to compare this to this, and I'll do that on the next slide. So I marked, so this is the standard normal curve now because we converted to z-scores, and the mean is middle, is 0, and here's our cutoff, that's our critical value. And then we've got a test statistic, which was what, like 0.198? Well, 0.198 is less than the critical value. It's in this region. And there's a colleague that I've worked with a little bit from White Mountain Community College, and when he teaches significance testing, and I like that he does this, he says, this is the happy place. You can't, HO can't be rejected, so I guess it's happy that it can't be rejected. So that's where this test statistic falls. It's not out here in the rejection region. It's not as extreme as that 1.28. So we can't say we can't reject HO. The claim that 85% of the people eat salads, more than 85% of the people eat salads once per week isn't supported by the data. Notice I'm not saying that we accept that we can't, or we accepted 85%. We just say that we can't show that it's wrong. Statisticians like to cover their butt, and rightly so. I mean, who knows if that 85% figure is correct? Okay, but we just can't show that it's wrong. Okay, so I hope that helps you make this. How do you decide? How do you reject or not reject HO? And how do you put that in context? Okay.